Hi guys, you're welcome back to Physics Solution. Today we'll be discussing the topic thermal expansivity. So let's dive in. Now, when we say thermal expansivity, it's actually resulted from the fact that one of the effects of heat is that it causes expansion. Yeah, it causes expansion in solids and liquid. But now we're starting with the solid first. Now, also in solid, we can calculate our expansion based on either the length, the volume, or the area. So when calculating for the expansion of length, we take use of linear expansivity, which is defined as the increase in length per unit length per degree rise in temperature. So in getting a formula for that, we say our linear expansivity, whose symbol is alpha, is equals to the increase in length per unit length per degree rise in temperature. So when we say increase in length, or when you hear anything increase in length, change in length, it means let me just say, anytime you hear anything change in or increase in, it means that the final minus the initial. So now, since we are discussing the change in length here, it means that what the final length minus the initial length. So by our L1 then times the change in theta. So we can also change theta to theta 2 minus theta 1 as well. Let me bring that out. So we have the alpha is equals to L2 minus L1 over L1 theta 2 minus theta 1. Now, so let's quickly, now this is the formula to get our linear expansivity. Okay, so we can now solve the question now. Before I move to the question, so the unit for linear expansivity is per Kelvin. So the unit of linear expansivity is per Kelvin. It is written as per Kelvin. Okay, now let's do a quick one on this question. Now in the question here, we are given that a wire of length 5 meters, so the L1 is 5 meters, is heated from a temperature of 10 degrees Celsius, that is theta 1 is 10 degrees Celsius, to 60 degrees Celsius. If it undergoes a change of length of 20 millimeters, so the change of length, let me clean that. So the change of length is 20 millimeters, which is same thing as writing 20 times 10 to the power minus 3 meters. So because when you divide 20 by 1000 to give you in meters, so you have to divide it into, we are solving in meters, so you have to divide the 20 by 1000. That will give you the value in meters and not in millimeters. So we have to find the linear expansivity. So linear expansivity equals to question mark. Now from the formula here we are given here, we say the alpha is equals to the change in length, which is this, over L1 then theta, change in theta. Now if you sort in our parameters, this will be equal to our change in length here. We are given there in the question, we have 20 times 10 to the power minus 3 over our L1 is 5 meters, times change in theta is theta 2 minus theta 1 from here. So we have theta 2 is 60, theta 1 is 10, that is change theta is 50. So if you press your calculator, you will get the answer, which will be 8 times 10 times 10 minus 5, and the unit of linear expansivity is per Kelvin. So this should be the correct answer to this particular question. So this is a very quick one, and I believe you understand how I solved it. Endeavor to go over the video again for more clarification. Also, I will appreciate your comments in the comment section, and also kindly